What's up guys, Shawnthebro here, and today we're going to be going over changing our hitbox data to be using data tables as opposed to just hard-coded values in the ANMBP. This will be important for a few different reasons. It's not technically required, however, it will make our lives a lot more convenient when we want to adjust data, especially if you're working with multiple people in your project. So when we come in here, and I realize I picked verses and not practice, so you can't see the hitboxes. But we have our attacks set up to deal damage, have a certain number of stun frames, and things like that. Well, if we wanted to change them before, what we'd have to do is go into the character's ANMBP, go to the specific hurtbox anim notify that we were spawning to create the hurtbox, and we would have to modify these values. Now, this requires a lot of moving around in the animation blueprint, and it requires a lot of keeping track of where everything is as well. And that can be annoying. It would be a lot easier and more convenient for people who don't want to go into the ANMBP if they had, for example, a file that had all the hitbox data. So I've only done it for these ones so far, but you could do it for all your moves. And I have this data table that stores everything we need to know about the hitbox. There's a lot more we will be adding here, such as hitbox lifetimes and other states that it can cause, or you know, if it can break through armor or blocking, and if it's counterable. These sort of things we can add to the hitboxes. We can do this for proximity strikes, projectiles. We can even do it for throws, which we'll set up later in this episode. But now say we want to change the damage that we do on this first, our basic light attack. And we want it to do 90% of the player's health. Now why we would want that, I don't really know. But if we wanted that to be the case, normally you won't have to compile your ANMBP anymore. I just still have the old logic in here. And I was showing that off. So if we look at this now, alright, so we come into our game, and we perform an attack, and you can see that it does 90% of the player's health, with huge hit stop because of the way our hit stop function is set up. So there you go. I can easily modify this value. Now if I wanted to, I could modify this in the middle of the game here, and it would literally modify how much damage is dealt to the player in real time, just like that. You can see it reads directly from the data table, so I can actually modify it now, change the hit stun frames, whatever I want to do here. I have full freedom over it, and I can modify it right here. I don't even have to exit and compile. Very convenient. And you also don't have to go find the specific logic in each ANMBP. Okay, so I'm going to show you how we can set this up today. If you're familiar with data tables, then this won't be too difficult, but we do have to change a lot of the areas that we're setting up our hitbox logic and where we also include it in the code. So we'll get started with the code today, speaking of. But before we get started, if you'd like to catch up, I believe this is episode 111 of the fighting game tutorial series. There are plenty more episodes to go, but we're moving along pretty well, and I'm really proud of what we've accomplished so far. So if you'd like to get caught up, I'll leave the playlist in the top right corner right here. You can see every episode we've done to date, including episodes that come out after this one. They'll all be put into that playlist. You can also go ahead and click this video here if you'd like. This is the episode on data tables, just generic data tables, so you can use them whenever you'd like. It's a more general example, so you can use them outside of this project. Might be worth taking a look at. Alright, then getting started, we have our hitbox actor.h and hitbox actor.cpp. And this is basically a class that stores all the data for the hitbox. Now, if we want to make a data table out of something, it requires a struct when you go to make it. So if you click add new miscellaneous data table, it requires you to pick a row structure. And you won't have your classes in here. So we won't be able to pick our hitbox actor class, even if we want everything that the hitbox actor class has, all the variables. What we can do is create a structure inside of our hitbox actor. I've called it fHitboxData, and make sure that you make it a child of public ftable row base. That's very important. Anytime you want a code structure to be able to be used in a data table that is made in blueprints, or otherwise really, so just in general, if you need a code structure to be used in a data table, you need to inherit from the ftable row base class. So that's what this does. This is making fHitboxData essentially a child of ftable row base. Now, to do this, you have to actually add engine.datatable to the top of your file. Engine.datatable is what gives you access to the ftable row base class here, so you won't be able to inherit off of it if you don't have this include. Make sure it is uStruct blueprint type so we can see it in the blueprint as well. And then what I've done is I've actually brought all of the hitbox variables from the class. So this is the class right here. This is what we've had. I haven't changed anything in here. I've just added that struct up top. But you can see I've added this structure, but it's not necessary for now. Let's just worry about what we had. We had hitbox type, hitbox height, hitbox location, hitbox damage, hit stun frames, block stun frames, pushback distance, launch distance, should cause ground bounce, should attach. The functions don't matter because we don't need the functions in the structure. We're not worried about that. If we're moving them to the structure, it's to move them to the data table, so we don't require any functions. They can stay in the class. And then if you want, you can make an instance of the structure. That way we can actually set the data in this variable instead of all these independent variables. This doesn't really make a difference in terms of performance as far as I'm aware. Like, I don't think this structure instance is any faster than all these variables because this structure is just made up of all the variables that we gave it here, which are the exact same amount of variables and the same sizes and types. The only reason this is important, though, is because we probably don't want two areas of this. We probably don't want the class variables and the structure. Now, technically, I'll go back to the code in a second, but technically, you don't have to do anything inside any of these functions. You can still set the class variables, and it will work. You can say, I haven't changed this function. I've added these at the top, but it's not even plugged in right now, so it won't execute. So create active hitbox is the same, and it worked with the data table. And that's because I'm still setting the class variables here. If you do this, you're good to go. You don't have to rewrite any of your functions or anything. However, it will lead to having two, it'll have all this data in the class, or excuse me, in the structure, and then you'll have all these variables in the class as well, which will get a little confusing to look at. However, you could be perfectly fine with that. If you don't feel like editing your logic, and I wouldn't blame you, you could leave your class variables. You could make this structure and not make an instance of the structure. If you don't make an instance of the structure, then it won't populate this with any sort of data. It'll just read the rows from the table. And if it reads the rows from the table, it's not actually generating this data. So it's up to you how you want to do it. If you'd like to go the structure route, I've implemented the methods here to show you what you can do, although it's not required. So this is what we had before in our animation blueprint. Again, I'll go back to the code in a second, but just as an example, this is my light punch. It's called rifle punch active because that's the animation that I've taken. But and this is another animation that I was just using the same exact hitbox for. But for now, just focus on this guy. So this is my light punch strike hitbox. So I've set up all my data here. Well, alternatively, if I set it all up in the data table row, and then I pull that row, break it down, I can pass all this data along into the create active hitbox, and I don't have to ever modify any of the other data. I haven't made an instance of that structure. I've just used the structure to grab this data here. So it will add a little bit of bloat to your overall hitbox actor file by adding that structure. However, it's actually perfectly okay if you don't want to go through and change the logic you have in these functions. So we're going back to the code one more time. I'll leave that up to you if you want to do it or not. I'll show you both methods. But essentially, for now, if you're undecided, you have to make a structure. So just make this structure. That's what you have to add today. All right. And now once you've made that structure, you'll load your game. We'll load the engine. And then let's go and make the data table first. Then we'll cover how you can modify your NMBP and hitbox logic to use the structure only if that's what you'd prefer to do. So go to where you want to make your data table. You're going to most likely want one of these for each character. However, you could also just have one that has a character index as well, or a character enum as well. So click add new, go to miscellaneous, data table. We're going to pick our hitbox data table, and we're going to hit OK. When we do this, it's going to make a file. You can call it whatever you want. I call it mutant hitbox data. I click into it. You'll have one row by default. Sometimes you might have more. Sometimes you might have 0. Depends on your version of Unreal. And I think there are also some default settings you can set up for data tables. But regardless, it's super easy to change. Just click on a row if you have one, and then you can edit. You can see all the contents and edit them. And you can click add to add more. And no joke, it's literally that simple. So all these columns here are the variables from the hitbox data structure here. A quick note, because I just thought about it as well. In the hitbox actor class, we're using a hitbox location. We don't actually put the rotation and the scale in the class. I only ever use the location. In the structure, I use the transform. Transform is made up of location, rotation, and scale, so it doesn't really matter here. I just made it a transform because I think it is better to have all the data in the structure. So I'd recommend updating that, but you don't have to do that. That's really just your preference. I just like it so I can change all three, the location, rotation, and scale right here. Because I want to be able to do it from the data table now. And so if I ever want to change the scale, which you definitely will, then I can. All right. And so when you have these rows here, when you add them, I'll delete these 3 so I can show you making a new one. So say I want to add a new hitbox. I can right click on the row and rename the row, and I can choose whatever I want for a name. So the naming conventions don't matter. They're just for you, just to know what they are going to link up to. If you want to be fancy, you could do something like grab the row name and line it up exactly with the Anim Notify's name. You could actually kind of automate the process if you name these things correctly in your NMBP. You could pass in a row name as opposed to manually picking it, and you wouldn't have to go through and set this up for each Anim Notify. However, I haven't done that because there are a lot of different cases with hitboxes in fighting games. I don't just mean the variables themselves, but some attacks have multiple strike hitboxes. Some attacks have like a single command may have multiple hitboxes that it creates, not just proximity and strike, but it could create more than one strike. It could actually go from, a melee to a projectile or a throw into a hit. And there's a lot of different mechanics here that you would have to kind of do separately anyway, because you may need to have very specific cases. So I'm leaving this open-ended to you. If you want to see specific types in the future, let me know. I'll try to implement those specific types of attacks so you can see my thought process behind it. But really, this is all going to be unique to you, so the data here isn't really too important. You can kind of see what I've chosen for each of these. If you care about my values, I will show them off. You can pause at any of those and check them out. So, like I said, we can rename this. I call it light attack. Hitbox 1 is almost always the proximity unless there is not a proximity box. Like for the projectile, I never created a proximity. Doesn't mean that you can't. You definitely can. Up to you if you'd like to or not. And so since I haven't, I just make it a projectile and call it 1. But really, I'm calling them the name of the move and then the hitbox numbered based on when it's going to come out. So it doesn't matter really if it's proximity, strike, strike, proximity somehow for one move. I mean, that wouldn't make sense. But my point is, it doesn't matter the order, doesn't matter the name, it's up to you. So say we want to do our, whoops, I call this the homing thunderball projectile attack. That's the one I have to charge up, and it's the electric ball. I'm going to go through, and I'm just going to set my parameters correctly. So this is a projectile hitbox. You know, you may need more hitbox heights because there are plenty of different cases as well. But since I don't really care in this case, because we're not at the point where we're doing the game design phase on the moves, I'm just going to put high as the height. That'll determine how the character can block against it. Then here is the transformation. Since it is a projectile, I'm not setting the location of the rotation. I'm allowing the projectile object to kind of manage that. The scale I can change if I'd like, but I'm not going to in this case. The damage, we can say that it's going to do 0.25 damage. Quarter of the health. Stun frames, we'll say 4. Block stun frames, we'll say 8. I'm just kind of putting in random numbers here. And we can put pushback if we want, and launch if we want. I'm not going to give it any launch. Let's give it like 15 pushback. I'm not going to allow it to cause ground bounce on the character. And I'm not going to attach it to the character spawning it either. Because it is a projectile, it's quite literally meant to leave the character. Okay? It's that simple. I set all my data for it here. And then whenever I want to go use it, it's this process that I was showing earlier. We'll go through it, don't worry, but this is all we're going to do. So I need to find where that hitbox is actually going to be spawned. So in this case, we'll just follow through with this example. So my homing thunderball is command 6 here, which is mutant homing TB. That's the name of my animation. And it has an anim notify on it called spawn homing thunderball. Now, if I go to my anim BP and I go to that event. Okay, so I found it. It's over here. I have my anim notify, and what we were doing is we were spawning the projectile actor, and then I was creating a projectile hitbox, passing in the appropriate data, and then calling spawn projectile. Now, again, this is perfectly fine. There's nothing wrong with manually setting the data in here, but it's a lot more work. It's a lot more me searching around the NBP to grab it. What I could do instead, say if I want to use my data table here, get data table row. Okay, we have to select our data table. I know I'm in the mutant, so I can automatically assume it's the mutant hitbox data, but feel free to, again, if you have a different setup where you have all the hitbox data in one file, however you need to search and find it, just grab the appropriate hitbox data file. And then you need to know the one you want to use. You can do this a little bit more manually, and I don't think this is an issue because each attack is going to be separate. So you can set the homing thunderball hitbox 1 here. If it's found, it'll return the data from the row. So we can break the hitbox, hit the down arrow to expand, and we get all the parameters that this hitbox will have. Then we can call create projectile hitbox here. And we only want to do this if the row is found. You may want to do something else if the row is not found. But the row should really never not be found unless something failed with loading the data table, or if that row, the row name you gave it doesn't exist. So if you manually put in a row name here. And then it's very simple after this. You just need to pass in your data to this function. So for hitbox type, height, transform, damage, hit stun frames, block stun frames, whoops, pushback distance, and launch distance. I have to just drag them directly into create projectile hitbox. This is a special case. It does also take the projectile reference, so I could just drag that in too. Then at that point, we're good to go. This will flat out just work. So I think I made it do 25% of the player's health. So let's test it out. Excuse me, I forgot to actually modify this though. So you can see what I've done is I've ignored this old create projectile hitbox. We'll clean it up in a minute. But we've gone from projectile homing to this new method where we use get data table row, break and get the hitbox data, and then pass it into create projectile reference. So if you want to clean this up, all you got to do is this. It's going to make some of this a little bit bigger, but it's going to make your life a lot easier. This is still pretty ugly. I apologize. But, okay. That should be good enough. Create a new reroute node there to pass in the projectile reference. And if you want, space it out a little bit so you can see. But, okay. So now we've updated our projectile, our homing thunderball. So what this is doing is, let's go into practice just to see everything. Be able to visualize it. And I'm going to click off the NMBP because it does lag the editor a bit when you have it open. All right, so yeah, I have to charge it up. I use it. There's my Hurtbox. Excuse me, my Hitbox. And now let's test out our logic. So if we did 25% of the player's health every single time, then we should actually be able to defeat our opponent, whoops, with 4 uses of this attack. There we go. And technically it brings it right to 0. And so the opponent does not die. But you can see that it took all their health. Quick bug fix here, guys. So the reason that the characters don't die when they reach exactly 0 health is because I never noticed it before. But when we were checking our is defeated from hit, we were simply checking if player health less than 0.00F. Basically, I wanted to be as precise as possible to make sure the opponent was defeated. However, we also want to include exactly 0.00F. So if they're exactly at 0 health, up to 2 decimal places, then we want to consider them defeated. There is one other spot we do it for the special logic down here during supers and how that differs. We covered that in the previous episode. Basically, you'll also want to add that equals sign right here. There we go. And you can see here that now we have defeated our opponent with 4 uses of the homing thunderball. We've reduced their health to 0.0. In which case, we're good to go. We can now change this as we please, and our Hitbox data will work as intended. You'll be able to modify it to your liking. It's this small change, and now this will always work from that data table. You can see I still have the other methods in here, so I'll want to go through and clean up all of these, and I will. But I'm not going to show you every single one, because if I did, that would be mind-numbing. However, you can assume that this method works for all of these. It will work for throws as well, but throws are a little bit different. Let's do a throw example. That way you have all the examples. You have proximity strike. Here are projectiles. Let's add a new row, and let's call it backward throw, because that's the throw I have. HB1. Now this is the grab, right? The damage that the throw does actually occurs on the anim notify in this case, because when the character hits the ground is when they take damage. I did this so that it would line up with the anim BP, with the animation. So once the character hits the ground, then they can see, then the damage applies. But you could also have a reference here, even if you don't really spawn a hitbox. You could actually make an entry here and pass in the data. This is all just data. It doesn't have to line up with anything. So let's do the throw first. Let's make this a throw. And I'm not sure if throws are usually their own, but I'm going to try none in this case. Looking at our NMBP, we don't define a height, so we've done throw, none for the height. I've repositioned it a bit. Let's change it to match what we have in the NMBP because I think that looks pretty good. 0.75 on the Y. I think those are all the changes we have. Perfect. So now our data matches except for the damage. So let's add 0.15 for the damage. And this is for the grab starting. Okay. So if instead of just using this create throw hitbox function and passing in the data, you know by now what we can do. See if I don't still have it copied, but I can copy this right here. I can bring it down, and we can bring in the appropriate fields. So I can choose the backward throw hitbox 1. I can now, if the row is found, pass in the data. And damage. Sorry, I was trying to figure out which ones I needed. There we go. And now this throw should work all the time based off what's in the data table. It's literally that simple. And by the way, remember splitting here? So when we break this hitbox data, I'll do it over here, and I bring this down, you see we have hitbox transform. Some of the nodes, like this create throw hitbox, I manually broke so that I could pass in the location, rotation, and scale. You can split them to do this. But really, in this case, if I wanted to, I could actually recombine this struct pin, recombine this struct pin, and then just pass in the transform to make it even neater. Since I don't have to manually put data in each of these entries now, and I can just pass it in from hitbox transform, that's nicer to look at. Okay, and this will work for when we throw our opponent, but like I said, here, we are just calling take damage when the character lands on the ground. This is to provide a visual effect for the player to say, oh, the health went down when they hit the ground. That looks a lot better than just taking their health away as soon as the throw starts or something like that. So I want to keep this logic, but maybe I want to be able to modify the damage in the data table. Well, guess what? You definitely can. You can call it backward throw. Now, we're not really spawning a hitbox here, so it is a little weird to do this. So you could call it backward throw, let's say, I mean, I want to say land, that works, but you get what I'm trying to say. It's when the thrown character hits the ground. So you could call it something special to remember it, or you could just basically assume that it's a hitbox again, like hitbox 2. Up to you how you want to do this. Really what we care about is grabbing the data from here. So you don't even have to set any of this if you don't want to. Like you can leave it proximity low because we're not going to be spawning a new hitbox. Really what we care about are these fields that we set data on. The only one we set data on was the damage amount. And so I could skip everything else, set the damage amount to be 0.2, and I could actually do this again. All right. I could do this again. Instead of throw box 1, we're going to do backward throw hitbox 2, I mean. And then we're going to pass this in. The only one we care about is damage. Now, you can also select the pins that you want on a structure. Like this is a pretty ugly node when we don't need all of these, right? We only need the damage. So I can hit hide unconnected pins, or you can manually choose the pins you don't want to show. Up to you. I'm going to hit hide unconnected pins because I only need the damage. And there we go. Now I have the damage from the table. Look how clean that is. And so now the rest of it I've left alone because I just don't care about them. I wasn't setting values for them. But let's test it out. So let's try. Let's play the game. Let's open up our hitbox data file. And let's test this out. So I have a throw that I can do by pressing 2 buttons at the same time, which is my light and my heavy. And there we go. 20 damage. That looks about right. I mean, it's kind of hard to tell based off that alone, but it looks about right. Now let's say we were to change this and make this 85. I save it. Whoops. And there we go. The opponent has died upon hitting the ground. So I can even do things like that. It doesn't even have to be a real hitbox. I can use this for the extra damage that occurs. So guess what that means? You could also do it for the super move. Remember, our super move looks like this. Okay, so we have our initial hit, and then I go into this if I land the attack. Well, that right there is perfect, because if I land the attack like I did, and I go into my super move, that flurry, if you saw, Oops, and I actually missed. I was just too far out of the range of it. And now this flurry that you see is doing damage every time. The HUD is gone for the visual reason, the visual purpose. Of course, if you have yours, that's perfectly fine. But you could modify each individual hit using the same method we just did here. Because the way our super move looks, it looks like this. So we have all of our super logic. Here's the super combo hit. It's the same as the throw, where we're just basically dealing this certain amount of damage to the player every time. What we could do is set up a value for that in the data table and pass the data table in. So you can set up all your hitboxes to be much cleaner. In terms of the actual like NMBP, sure, there might be more nodes because you need to get the data table row, but you can just easily modify it here, even while the game is running, to get these different results, to align your hitboxes perfectly, because you can keep changing the location in the middle of the game. You know, you can play around with combos and launch distances. And again, other people, if you have other people working on it who don't want to go into the NMBP or don't normally work in the NMBP, they can now just look here and edit these files. Now, at that point, I'm actually pretty happy with it. I think that's pretty much good enough for this episode. However, if you do want to clean up, say you do want to clean up and you do want to actually get rid of your class variables, because you could delete all the variables in this class other than that hitbox data variable we made, okay? So you could delete them out of here, everything I've highlighted, and just keep the ones in the structure instead. If you did want to do that, this is what you would do, okay? So how we're doing it before is we're spawning a hitbox, we're grabbing the variables from it, and we're setting the data appropriately. All of them individually, as well as the rotation and actor scale. Okay? What you could do instead of setting each variable individually, you could drag off the hitbox actor BP, get the hitbox data variable. This is an instance of the structure that we made. Okay, right here. Now, this, if you drag off of an instance of a structure, you can type set members, and it will let you set the members. Here we go. That way it's cleaner. Let you set the members inside of this structure. The same as we hid the pins, you can enable the pins to be set in here. So you could set this for each of your functions: create active hitbox, create projectile hitbox, create proximity hitbox, create throw hitbox. You could choose the pins you need, because we know that they don't need all of them. And then you just drag them in the same way that you did everything else. Player transform, okay. Well, actually, player transform has to go into these other nodes. These are all nodes to say, take the player's transform and add or subtract from it based on the direction the character is facing. So you'd actually take these results. You'd split this pin. You would take the result, and depending on what this branch came out to, you could set it to one or the other. Okay. You could take the... You won't have these variables anymore here. Whoops. So you could drag directly from type in here, hitbox height in here, damage in here, just like that. And then when you want to grab them, you can always either break this node right here, or if you have your hitbox data variable at all, you just type break, and you can grab all the data of that specific hitbox. All right, and so you could do that for all your functions in your NMBP. If you do end up going that route, you'll also have to edit the hitbox actor BP right here. And I've already done this for you, but this is hitbox actor BP. So it is a child of hitbox actor, which means we have access to that hitbox data struct variable. And what you could do is type get hitbox data. And then you could either click on the right side here and figure out what data is in it. Or you can simply, instead of breaking it, if you don't want to do that, you can right click on the little pin part here, split the struct pin, and then you have access to all your variables. This is important in the hitbox actor BP because we do call take damage if a collision is found on these certain cases. And so you may have to pass in damage, hit stun frames, block stun frames, instead of these variables, because if you're removing them from the class, they won't be here anymore. So you'll have to grab them from this structure. I'll be running some tests to figure out which one's the best, and if we end up needing to adjust it in the future, we can. But it'll be a pretty easy fix. It's just going to be editing. It's just going to be cleaning up a lot of the data that's going to take some time. So we don't need to go into that right now. But honestly, guys, that's about it. So I hope you enjoyed this episode, and I hope I helped you be able to modify your hitboxes and honestly your attacks in general to your liking. It is very cool to be able to do this in real time. And in fact, I'm gonna even play around with the location here of a hitbox while I'm playing here, while I'm doing my outro. So yeah, guys, if you enjoyed what you saw, please subscribe. It does more for myself and the channel than anything else you can do, and I just really appreciate it. I want to give a huge shout out to my YouTube membership, Patreon supporters and subscribers. Thank you guys so much for the love and support. I really, really appreciate it, and I can't tell you how much it means to me. I'm so excited that I get to show you guys this all the time and all the updates that we do to this series. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. Be happy to help you out with any of the issues you had. It's completely free. Anyway, guys, that's all I got. So thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.